So after we have our math here for our Q value, our BTUs per hour that we need, our BTU hours we need to heat the house based on transmission, we got to look at the air leakage as well. So we'll make what's called an infiltration calculator. Infiltration calculator. Did I spell that right? I spelled infiltration calculator right. If you don't remember, F7 is the key for spell check. Please spell check your work. So the infiltration formula is very simple, just like your Q equals UA delta T for transmission. It's very simple formula. So we're going to have our Q again, but this time instead of being UA delta T, it's going to be V, which is volume, ACH, and you want to take a guess what ACH is? Air changes per hour, times 0.018, which is a constant. Does that make sense? So what we're going to do is we're going to have a couple different items here. We're going to assess a house based on, let me leave myself some space here. V is volume. Tight. Medium. Tight, medium, and loose construction. Okay. And we're going to go, I'm going to call these outside design temps. Outside design temperatures. Okay. And then we'll see if I left enough room here. 50, 40. Let's see if Excel gets the hint. It does. So what I did was I typed 50 and 40, right, which are 10 apart. So if I highlight both of them and then use that quick copy function, it knows that I want to subtract by 10 each time. And I'm just going to go to basically a minus 40 here. You guys with me so far? So we're going to build a chart down here. We'll get to that in a second. And then you go up here, and we're going to build our formula in. We'll keep the same kind of format. So we're going to have our volume in cubic feet times, and I'm going to auto fit that so it actually fits. Our air changes per hour, which is just a number, if that makes sense. .018, which is our constant, equals our BTUH. So that's our formula headings here, right? So this formula, VACH 0.18, VACH 0.18. You guys with me so far? So I'm gonna build just a spreadsheet here that we'll just assess a median for now. 0.73, 0.77. These are your air changes per hour based on the different design temperatures. Take them out of a chart. Yeah. The volume ACH and 0.18 after we're gonna do a math. We're gonna multiply the volume of the house, your air changes per hour times 0.18. But we need our air changes per hour first. So these out of a chart. It should be a 0.41. It's probably my formula didn't work before. I was just trying to get these to go up by a progressive amount. 1.110, 1.19, So you'll end up with a chart like this. There's probably, if you look in that book that I gave you guys from NYSERDA, there's probably a chart published with air changes per hour based on different design type. These ones here came out of chart that I'm using here. I can put it right in here. 1993. And it was page 42, table 2-9. No, I gave you guys a new version. I found these ones I had in. I had a copy of this laying around when I made my template. That's where they came from. So what it is the definition's like a tighter house, close fitting doors, windows and frames, new construction, maybe something reasonably sized. A medium here, right, would be a larger house, older, average maintenance. Maybe it's got a fireplace, something like that. And then loose would be a poorly fitted, windows. Older house, maybe it's a fireplace that's older that doesn't have a damper, just a lot more air leakage. Does that make sense? So you can see if you follow the chart that these ACH numbers, I guess I should label this chart here, ACH numbers, right? B. Right, these are the outside temperatures. If I outline them, maybe that's easier to follow. outside design temperatures, so from 50 degrees to minus 40 degrees. So the greater the temperature differential, the more air leakage you're going to have. Does that make sense? We just looked at our stack houses, right? And with the stack houses, when we turned our light bulbs on initially and you lit up the fog machine, nothing happened. But then as the house got warmer, there was more of a difference in temperature between the classroom itself and the inside of the house. Your delta T was greater. You had more airflow through the building, right? You guys visualized it. You guys did it. So these numbers get larger, right? You start with 1.11, you go up to 1.57, right? They go up quite a bit just based on the temperature differential alone. The quality of construction, of course, that has quite a bit of difference. We almost triple. Okay, so if we can take our sheet here and we can say that we are a medium fit house, make sense? So a house that's, maybe we're buying a house and we're trying to figure out our energy audit, or we're a architect or a builder designing a remodel, we're doing an overhaul, and we want to design the heating system to be able to heat the new space, or we're replacing a heating system. Maybe the owner complained that the house was always cold, or this bedroom was always cold, so we want to make sure the house heats evenly. We look at it, we'll say the medium, fitment. Okay, so I'm going to look at this. Our volume of our house. Do we know our volume? We haven't had to do volume yet as far as the math formula, right? So that our volume is going to equal our overall square footage multiplied by our height. Does that make sense? Our air changes per hour, we could do a really fancy formula. Maybe next time we're in a computer lab, I'll show you guys how to write a logic statement that will automatically determine this. But for now, we're just going to hard number in here. So we are at our delta T. Our inside design temperature is 70. Our outside, we didn't have that much delta T on here, do we? Oh, it's not based on delta T. It's your outside design temperature. 0, right? So our outside design temperature is 0. So we have our outside design temperature, 0 degrees. So we're going to go here. This. 0.018. And then this is just going to simply be a multiplication formula. It's going to be this, multiplied by this, multiplied by this. Well, that's a really weird number. B31. 19,200.89. 307. Works. Okay. My math works. So we have, the heat needed, I guess I should have left myself a little more space in here. I'm going to insert a couple rows. The nice thing with Excel is when you move things around, the formulas kind of adjust for that. You can see like this air change per hour, retain that link even though I moved it down a couple rows now. So this, right here, I'll bold it. We're using 12,000. We need a heat source capable of 12,934 BTU hours to heat our house, just based on transmission, heat loss through the walls, and 307.584 based on